The Renaissance's cultural revolution is often seen as a period of enlightenment in which art, politics, and philosophy bloomed, and from the glory of their blossom, the sciences and mathematics were not exempt. In the later years of the movement, they sprung forth with ideas, including the Copernican model of the solar system, the Cartesian plane, Kepler's laws of planetary motion, logarithms, and our much beloved calculus. Its creation, or arguably its discovery, sparked a rivalry between two great polymaths, Sir Isaac Newton and Gottfried Wilhelm von Leibniz.
The former was a British astronomer and physicist, and the latter a German philosopher, both with significant contributions to their respective fields. The independent yet practically concurrent works by the two men would lead to a fiery dispute with nationalistic implications that would reverberate for years to come.
But how is it possible that both Newton and Leibniz happened upon the same thing, living in different nations and in different conditions? How is it that two men, separated by hundreds of miles, learning about mathematics in different ways, happened to come across the same conclusions? The answer: math was not something that was invented, but rather discovered. Mathematics is the abstract science of quantity, numbers, and space. Calculus is defined as the mathematical study of change. As seen here, mathematics is considered a science, and by extension, calculus then becomes a scientific study. Science itself was not invented, but rather discovered. This is seen in our everyday world where we use the term scientific discovery.
The greatest of minds joined together in postulations and conjecture progress towards simply uncovering more of what we have not yet discovered, veiled not by falsehood and non-existence, but rather by our own inadequacies in perception. Much like two wandering explorers setting foot on the same uncharted territory, and claiming it as solely their own, they have erred. For its existence, much like mathematics, lies independent of human creation, and consequently, its discovery must be treated as such. The two men's interpretations are bound to be different, just as Newton's Fluxions and fluents varied from the differentials described in Leibniz's Nova Methodus pro maximis et minimis. To an observer, the two were definitely describing the same mathematics.
Imagine the two explorers from before landing on a deserted island. They both perceive and describe the island in different ways. However, if they were to draw maps of said island, both would be the same. This is also true of Newton and Leibniz's works. The way humanity perceives the universe is also much of the same concept. The term observable universe is used to denote how much of the universe can be seen by humans using a variety of methods, such as telescopes and space probes. However, humanity cannot perceive what is outside this realm, and we are led to believe that there is nothing else. This could be untrue, as discoveries are made every day as technology continues to evolve. Mathematics is quite like this as well, as both Newton and Leibniz discovered calculus rather than inventing it.
Overall, when it comes to discovering identical principles in math, it can confidently be said that the two were not the first and will likely not be the last. Such an occurrence is not the first of its kind. In the same century, the French lawyer Pierre de Fermat had rediscovered Thabit ibn Qurra's method for finding amicable numbers. If Ibn Qurra did not discover the method, Fermat would have, something that can typically only be said about pre-existing discoveries as opposed to newfound inventions. Similarly, if Pythagoras did not discover his eponymous theorem, or Columbus had not discovered America, another figure simply would have. If neither Newton nor Leibniz discovered calculus at the time, someone else surely would have. A.K. Dewdney, Ph.D., author of A Mathematical Mystery Tour, discusses in it the idea of the holos and cosmos. Holos is the term used to refer to the realm of independent mathematical truths, whereas cosmos is described as its manifestation. The contents of the holos, mathematics itself, is simply waiting to be discovered, pre-existing the discoverer. It's the realm of axioms and discovery. Dewdney describes how different mathematicians, when given the same axioms to work with, are bound to eventually reach the same conclusion. In this case, identical axioms were definitely laid out for Newton and Leibniz, with the example of the earlier creation of the Cartesian coordinate system by the French philosopher and mathematician René Descartes. Logically, by considering the nature of mathematics as something that pre-existed a discoverer, the two came across identical discoveries. It seems only fitting after all.
Created using Powtoon.